Good evening everyone. So basically this car has a fault code P00BD, which is mass airflow sensor circuit A performance high. So that's a very popular code too. I've seen it many times for multiple different regions. This is not a very easy diagnosis to do, but it's very easy to do once I show you what is causing this. So basically customers complain is just a check engine light, there's no performance issue, engine's running fine, starting fine, everything is good, just the engine light coming up on the dash and staying on. Now there is no fault code at the moment because I raised it while I was doing the diagnosis, so I can't show you the fault code on the computer, but I'll walk you through the process if you got this fault code, right? But before I get to it, I want to quickly do a quick, you could say a review on this tool. This is a Mucar CDE 900, okay? This was sent out to me to do a review and, you know, just use it and see how it works. Obviously this is not something my go-to tool is in the shop when I'm working. Obviously this is a busy shop, I got a lot of diagnosis to do here every day, so this is obviously gonna slow me down. But again, this is I don't know, $60–100 depending where you buy it, to a very cheap tool. So this is a OBD code reader, but is also give you a software update if you pay a little bit extra. I think it's about $40 if you pay. They'll give you an update so you can get into the car's ECM, airbags, ABS, and a couple of other things. They will upgrade it for you. If you don't upgrade it, I'm pretty sure it only does OBD2, which in some cases is enough. For this instance, for this car is enough. So I'll just use this every now and then. If I just want to quickly see the codes, if a customer only asks for a quick code, I do use it, okay? So I'll show you how it works. I've been using it a little bit for a while now. I just wanted to see how it works first. Obviously this was given it to me, so you could say it's a sponsor video, but again, it's not really. The sellers has asked me to just be honest about it and give an honest review. So I'm gonna do that. If you're considering just DIY, do it yourself at home, just your car or your neighbor's car, and you just want a reader, this is pretty good in my opinion for $60–70, you know, to buy. Okay, so it's got a pretty large screen and it is very quick as well. I've noticed that. Okay, so let's get into it. I'm gonna plug it in and I'll show you how quickly this one reads. Okay, it's very quick. So I'll just plug it in, turn the key on, right? As soon as you turn the key on, plug it in, you don't even have to hit the power button there, it just automatically turns on itself. It's very quick. So if you want to know the problem with your BT50 Ranger, you're going to have some patience with me because I really want to do this first. But along that review process, I will definitely show you how to diagnose the problem using the tool as well. Okay, so it's loading up. It's very quick, less than 30 seconds. I would say it's already on. Okay, there you go. So now we can go and check the fault codes, whatever you want to do from here. So once you're on the home page, this is all the OBD function. It gives you onboard monitoring, O2 sensor test. Of course, it gives you live data stream, erase, code, freeze frame. So it's very easy to read the codes as well. If you just hit that button and go read codes, it really easily reads the code. At the moment there's no codes obviously, so you don't see anything right there, right? So that's quick. Okay, and you can also read the live data through there, very quick, right? I've tried it in many cars. It is actually a quick tool. Okay, so you can read all the live data currently from this engine. It's got expand function here that will give you that you have to purchase that 4-in-1. So ECM, SRS, TCM, ABS. Okay, you got to purchase that in order to use this extra function, so you can really use that as well to your advantage. if you want a little bit more than just the OBD2, okay, that function is always available. So we can just go and diagnose this car. It will auto search the VIN number for us. So as you can see, it's trying to read the VIN number from the ECU. So it has read the VIN number from the ECU now, so we are connecting to the vehicle. Okay, and it is very quick. Very surprised with how quick this tool is. Okay, now we're here. We can do a full system check, or we can just select the system we wanna talk to. Obviously, we can talk to ABS, PCM, RCM, and the TCM. Obviously, this car has more than just 4 modules, but this is what they support at the moment. They might have new updates in the future. I don't know about. Alright, let's just go into PCM. That's our problem. Alright, before we get into it, I want to quickly show you one more thing. Let me just come back all the way and go to the home page. Alright, this one also has a function. If you connect it to your internet Wi-Fi, you can also go to other OBD diagnostics function. You can go to DTC lookup and you can put that any DTC here, and it will show you the description and all that, what that code meant. Okay, so in this case, this one is keep coming up with P00BD. Okay, you can go search and it will show you mass airflow sensor. You can read there, too high airflow is caused by error in MAF sensor air circuit. Alright, give you that description right there. Okay, and down here you see that circle icon. So if you press that there, it will take you to the Google page if you got your internet hooked up, and you'll search it on the Google about that fault code that you're trying to figure it out. Okay, so that's a cool feature there. Now let's go back into the system. Let's go to PCM. Alright, I'll show you how to diagnose this problem. There are few things that can cause that fault code that I've seen with my experience, right? Okay, so there's no fault code. So let's go to the read live data stream. Every time I get this fault code on a BT50 Ranger, this is my go-to procedure. Okay, so what you're gonna have to do first thing is you're gonna have to find the turbo pressure, so intake manifold pressure. So usually I like to go just scroll through and find where that intake manifold pressure is. Okay, manifold pressure sensor, and you can select that and it will take you to the graph page. Okay, like that. So now we're reading the graph. Right now it's sitting about 96 kPa, which is atmospheric pressure. Obviously engine is not running. So what I like to do is I like to start the car. Obviously let the car run for a little bit before you do any revving on the accelerator. Obviously you don't want to rev the engine when it's cold. Let it warm up a little bit, and then I'll show you what you're gonna do. So obviously the car is running. Obviously we haven't revved the car, so we are sitting at about 95, 97 kPa, which is normal, right? Around that atmospheric pressure. I like to rev the car, and I want to see what's the maximum value this manifold pressure gonna get. Okay, I'm gonna rev the car now. Okay, just like that. Just rev it very, very quick, you know, wide open throttle. Okay, like that. As you can see, it's hitting about 180, 190 kPa there. Alright, try it again. Okay, so just like that. Now, every time I do this test while idling, we're not driving, we are just sitting in the shop idling. Every time I do this test, I want to see this hits close to 200 kPa. Okay, if it hits close to 200 kPa, I know there's no leak in the intake system. Okay, that's what it means. If we see a very low value, less than 200, let's say less than 150 you got a large leak in that intake system. So you got to go out there and figure out where the leak may be. Other thing I want to show you, it's a very common problem. It throws the exact same fault code. It throws a fault code for the mass airflow sensor P00BD, but it doesn't actually throw the fault code where the problem is. Okay, I'll explain to you what I mean. So in this case, the problem is your air temperature sensor. Okay, that's what the problem is. So in this car, there's two air temperature sensor. One is in the mass airflow sensor, and one is on the turbo line, as in on the intercooler in this case. Okay, it reads the turbo charged air temperature as well. So that's where the problem is in this car. I'll show you the data. Okay, so if I scroll down, right here you can see air charge temperature sensor. It's sitting at 118 degrees Celsius. Okay, and that is very, very incorrect. It shouldn't read that high on the charge air temperature. Okay, if I rev it up and down, it doesn't really move up and down too much, maybe 1 degree up or 1 degree down, but it's sitting at 118 degrees. So that is our problem, guys. Okay, now I'll show you the voltage reading as well. I just have to find it, guys. Just bear with me. It's here. I just have to slowly find it. There you go, right there. So we got 0.6 volt that sensor is reading, and which is 118 degrees Celsius. So that is wrong. So this is the reason why this car keeps throwing that fault code. Okay, I'm going to go out there and I'll show you a couple of more things there. Basically, before I go there, I just want to say thank you for sending me this tool. Go check it out if you are a DIY person. Go definitely check it out. This is a pretty good tool in my opinion for your own vehicle, or if you only do electronic diagnosis here and there. Great tool for 50-100 bucks, very cheap. There is two temperature sensor on the air intake. So one is right on the mass airflow sensor here. This is also a mass airflow sensor integrated with the temperature sensor right there. Okay, also down this area here, just in front of the radiator on the intercooler that sits right here, it's bolted on the passenger side, on the left hand side. On the intercooler itself, there's another temperature sensor that's called charge air temperature sensor. Okay, and this is called intake air temperature sensor. Okay, so with our fault code, it says P00BD, and I showed you on the live data that this charge air temperature sensor which sits in front of the car is not reading correctly. Okay, I got the car turned off at the moment, and I got all the live data on my scan tool. Okay, and you can definitely do this with that tool I showed you before. So charge air temperature on the top is 118, the car is off, it shouldn't be that hot. Okay, it's already a red flag right there. Charge air temperature sensor voltage 0.55, not that it means a lot without knowing all the information. And intake air temperature is reading 31. So the computer is reading 31 on the mass airflow sensor, but it's reading 118 degrees Celsius on our second temperature sensor. Okay, so there are many videos out there. If you type in that fault code P00BD, there's a lot of videos people showing about broken intercooler hose or cracked intercooler hose, which is very common, and that throws the exact same fault code too. So what they're talking about on the internet is, I'll just show you in which area the broken hose usually is, and I've actually have marked it right around this area. You'll see a big crack. When you rev it, you might even feel or hear the hissing noise, the air noise escaping from the system. Now, I've seen on some cases the intercooler actually had a leak as well. Obviously, it sits right on the front. The stone can hit while you're driving on the road. They can fail as well, obviously, right? And you could have intercooler hose leaking on this side as well, where out of the turbo. So the leak could be anywhere in the manifold anyway, okay? So for that reason, if you suspect there's a leak, and that would be my first thing to do, obviously, if I didn't see the temperature sensor reading incorrect, right, like we saw on this one, definitely do a smoke test right at the air filter box and smoke the whole intake system. You'll figure out if there's a leak or not. And if you see absolutely no leak, obviously next thing would be that temperature sensor, okay? Now this is a very common area right where I marked it, so make sure you just visually check that as well before you waste all your time. Okay, now let's get into the temperature sensor. So it is right here. I'll show you quickly, and we'll do few testing here. I'll show you how to do quick testing, the wiring integrity testing and all that, and then we go from there. Okay, there will be a 8mm bolt for this plastic. So obviously on top of it there's also a cover which I have taken off already. Couple of clips, it will pop out, and then you got to remove that plastic as well from there. Okay, so there will be one more at the bottom, and then this plastic will come out. So just like that, you pull the plastic cover off, okay? And then on the plastic cover itself, there is another sensor, looks like an ambient temperature sensor, the outside temperature sensor. Engine and computer AC system can use that as well. So you can disconnect that, or you can just leave it there. You can actually get to the sensor now, but just actually I'll just leave it there. I'll just move it aside so we don't throw any extra fault code. So I don't want you guys to be confused here, that's all. So down here there's a green color sensor with a 1 bolt, looks like a 10mm, okay? On the intercooler itself it's bolted up to, okay? Okay, right here, that's the sensor, that green one. So we'll leave that air charge, temperature sensor, degree Celsius, voltage, and also the intake air temperature right there. So sitting at 0.55 volt, 117 degree, okay, as you guys can see. So I'm going to reach down there and I'm going to unplug the sensor now, okay? Alright, the sensor is unplugged. As soon as I unplug the sensor, you can see my charge air temperature voltage went up to 4.99, let's say 5 volt, and my air charge temperature is 20 degrees Celsius. Okay, so that's the right temperature we dealing with. So we're not worried about the intake air temperature sensor, that's in the mass airflow sensor. Okay, now we can go back to trouble codes and we can see, it'll show us the trouble code for that sensor now because we disconnected it, right? Intake air temperature sensor 2 circuit high. So on the fault code it says intake air temperature, which is description is a little bit flawed here. It gives us same description, which is the same thing, the meaning is, but on the live data it says charge air temperature sensor for this one and intake air temperature for one at the air filter. But on the fault code it says intake air temperature sensor 2, so they're referring this as sensor 2 and the one in the air filter or mass airflow sensor as sensor 1 circuit high, which we know that's going to happen because we disconnected the sensor, right? So now at this stage what we can do is we can check the wiring integrity, but just disconnecting that, if you go back to live data, just disconnecting that is enough to know that our wiring is good, the sensor is the fault, and I'll explain to you why. Let me go back to that data again. So we got charge air temperature and air charge temperature, okay? Let me get rid of those two away. Okay, so just by disconnecting that it jumped to 5 volts. So if I connect it back up again, it's gonna go back to 0.55 volt that we saw. So it jumped up to 0.55 volt right there, you can see. right? As soon as I disconnected it, it jumps to 5 volt. So what that means is our 5 volt reference is present at the sensor, okay? And our earth is present, that's why it's dropping that voltage down. So we don't necessarily need to check anything on this wiring because it should be good. Okay, but just for our satisfaction, I'll just show you quickly what to do. If you really want to go to that extent and check it anyway, I'll show you how to do it very quickly. So for this one, all you need is a test light and a multimeter. Okay, now first thing we're going to use is just our test light. Okay, I'm going to connect my test light to battery positive because we're going to look for earth here. Okay, as soon as I find the earth here, let's just use this body on the chassis, right? My test light gonna light up. Okay, so I'm just gonna reach out to that harness there, and I'm gonna check for power and earth. Okay, so one of these, I don't care at this stage which one is what. One of them going to have earth, and another one's gonna have power in it. Okay, that's how it's gonna work. Okay, so test light connected to battery positive. I'm trying to find earth on these plugs. I don't care, I'm just gonna go one at a time without damaging the terminals, obviously, right? There you go, I got earth on my sensor. For the sensor, one of the wire, which is, I don't really care what wire is what, I know I got earth here at this stage. Okay, there you go, test light lights up. Now we're going to use our multimeter and we're going to find that 5 volts. Okay, there you go, 4.98 volts. So we got our 5 volt reference voltage is present there. So we are basically done with our diagnosis here. It needs a new sensor, it's not reading correctly. That's what causing the airflow sensor fault. Okay, at this stage we've done our diagnosis. You can turn the video off and go on about a day, you know, but if you want to stick around, I want to show you something else on the board. This is just for learning and teaching. You know, if you want to learn and know hows and whys, stick around. If you don't want to learn, I help you fix your car. Leave a like, thumbs up, subscribe, comment, and you turn off the video. The guys interested in learning, stay with me. Alright, whoever stayed, thank you for staying with me. Okay, let's get into how and why. Okay, now this can apply to many vehicles. So that's the fault code we are getting, P00BD, right? So it's saying mass airflow sensor is reading too high. Okay, this is too high. Okay, and then number one, I said to do the smoke test on the intake, smoke testing. Okay, find out intake leaking. Why intake leaking will cause exactly the same fault. Let's get into it very briefly. So when there is an air leak, so let's say you got an air leak, right? The turbo is making the pressure, right? So this is a turbo, let's say. Turbo is going to make a pressure, it's going to go through the intercooler, right? And it's going to come out and it's going to go to our intake manifold and in the engine. Now on the intake manifold they got a MAP sensor, manifold absolute pressure sensor. Okay, so the MAP sensor wants to read, like I said, when you revving at idling on scan tool, you need to see almost 200 kPa. Okay, always remember that number, 200 kPa. If it's not hitting 200 kPa, there is an issue. Whether the turbo is not making boost, whether the leaking is on the hoses, leaking is in the intake manifold, leaking on the intercooler. Okay, there is some kind of leakage that turbo boost is escaping. That's what it means. So for some reason on this Ford Ranger and BT50 they put too much priority for mass airflow sensor. Okay, that's how the engineers build that car, build that software. Okay, too much importance. Nothing wrong with the mass airflow sensor. So mass airflow sensor is not gonna fix this car. Changing it doesn't matter how many times you change, it's not gonna fix this car. Okay, so if you have a crack intercooler hose, let's say here, there's a crack, all the boost is leaking. Computer wants to see, when you rev the car, it wants to see, let's say 200 kPa, but it's not seeing 200 kPa, right? So what does computers assume? This is how they wrote the program. Okay, I'm not an engineer. This is how they did it. This is my understanding. Okay, I could be completely wrong, but hear me out. This is my understanding why it throws the fault code when you have a broken hose. Computer seeing very less pressure in the manifold when you rev the car, but the mass airflow sensor is reading the same amount whether there is a crack or no crack. Okay, so mass airflow sensor is reading the same number, but the manifold pressure is less because the hose is cracked and escaping the pressure. Okay, so computer assume that there's something wrong with the mass airflow sensor. I'm reading too low on the manifold absolute pressure sensor. The mass airflow shouldn't read that much air coming in. Okay, that is why computer throws that fault that mass airflow sensor flow is too high, P00BD, if that makes sense what I'm trying to say. Now second scenario is in this case, right, there's no leak in the intake system. The problem was the charge air temperature sensor. Charge air temp sensor was the problem. And it was reading 118 degrees Celsius. Okay? Same principle applies here like the first scenario. When the air is hot, okay, the air density is going to be less. So when you heat up the air, the density is going to be less. Okay. So what computer is seeing here is, okay, my air temperature is very high, 118 degree. So my mass airflow sensor should read less because the density is low in the air, right? That's going into the engine. But the airflow ratio is reading the exact same amount that it should, and usually it's reading whatever it has to read. It's going to read because there's nothing wrong with the mass airflow sensor. But computer calculates, okay, my temperature is too high. This airflow sensor shouldn't read the amount it's reading because of that temperature sensor. Okay, so that's why a computer thinks, or that's the software the engineers wrote, is okay, my mass airflow sensor, something wrong with my mass airflow sensor, it's reading too high. Throw a fault code. So that is why the mass airflow sensor is reading high fault code, P00BD comes on because of the bad charge air temperature sensor. Now, how does this work? I'll quickly show you how does the charge air temperature sensor work and what testing I showed you before, how it worked, what I did. All I did is disconnected the plug and I knew the sensor is bad. Why? Because I was reading the data on my scan tool. As soon as I disconnected, it jumped to 5 volt, meaning there's nothing wrong with the wiring. The computer can read just fine. Okay, it's just the sensor reading wrong. Sensor is not sending the right signal for the computer to read the temperature right. Okay, so that's what happened. Now I'll just quickly show you how the temperature sensor works, and this applies to any temperature sensor that they use on the automotive. Doesn't matter what car it is, from Chinese car to American to European car, they're all gonna work exactly the same. They're gonna have 2 wires coming out of the computer. So this is your computer, let's say ECU. So you're gonna have 2 wires coming out, and this is going to be your sensor. Okay, and then sensor is gonna need a 5 volt. So let's go 5 volt source here. So one leg of the sensor is gonna be 5 volt, and another leg of the sensor going to be our earth, negative. Okay, and that's negative gonna go to its negative source. Right? Now, how does the computer reads the voltage difference? So basically, computer doesn't know what the temperature is. Computer only knows the voltage difference. That's how they calculate inside the computer what voltage means how many degrees Celsius. Okay, that's all done in this programming in the computer. So this reads there. So let's think of it as a multimeter, like a digital voltmeter. It reads voltage right here. Okay, whatever it reads there, that's what you're gonna see on the scan tool as well. So on a temperature sensor, after the 5-volt source, what they're gonna do is they're gonna have a resistor. So the voltage is read between the two resistor. Okay, that's how they calculate the voltage for the coolant temperature, and this works on any temperature sensor: coolant temperature sensor, air intake temperature sensor, AC temperature, ambient temperature. They all work the same. If you know this, you can tackle all the temperature sensors in automotive, including your engine oil temperature sensor, transmission oil temperature, exhaust temperature sensor on DPF. They all work the same. 2 wires, 5-volt earth. So once I disconnected the sensor, what I did, I read 5-volt with the multimeter on one wire, and I read earth. Okay, my test light lit up. So we know both our earth and 5-volt is present at the sensor. Sensor is faulty. Okay. Now, on the scan tool, as soon as I disconnect the plug, my scan tool went from 0.55 volt to 5 volt. Why? Because on the voltmeter inside the computer where it reads, went to 5 volt. Why? Because I disconnected the path for that 5 volt to drop, right, to the earth. Okay, so I disconnect the path to the earth. So what's going to happen? This 5 volt's going to go through this resistor, can't go this way, so it's going to travel through the multimeter or digital voltmeter, whatever they use inside the computer. I'm just giving you an example. Okay, to the earth. This voltmeter gonna read now what? 5 volt. Okay, that's why the voltage went very high, 5 volt. Now, if there was an open circuit in the wiring, let's say there was an open circuit, so the voltage, so the sensor was never getting the 5 volt. So what would you see on the scan tool is you're going to have a fault code for a high voltage for the air temperature, because this is always going to read 5 volt because there's no path to ground, right? And disconnecting that sensor, the plug we did, is never going to make any difference. So if you look at the scan tool live data, it's going to stay 5 regardless you disconnect or not disconnect. Then you really need to check the wiring circuit and everything and find out where that 5 volt is broken, okay, or the wire is broken. So if the earth was broken, same scenario. This 5 volt will never see earth to drop the voltage. The scan tool always gonna read 5 volt, regardless you disconnect the sensor or you don't disconnect the sensor. It's always gonna read 5 volt. But in our case, it was 0.55 when it was all connected. As soon as I disconnected it, jumped to 5 volt. Tells me there's nothing wrong with the wiring, nothing wrong with the earth, nothing wrong with 5 volt, nothing wrong with my computer. Okay, that's why I said I don't need to do anything further. I already know the sensor is bad. Let's say if this was shorted, okay, let's say this 5 volt was shorted to ground. This is going to read what? 0, because that 5 volt is dropped straight to ground. So this is going to read 0, that's what you're going to see on the scan tool, and the fault code is going to be circuit voltage low. That's the fault code you're going to get. Disconnect this sensor, is never going to change that reading. Never going to change that voltage reading for that sensor. Okay, in that case you need to go and search where that short is. Let's say the short is inside the sensor. Okay, the short is inside the sensor, shorted together, right? Disconnect this. So the meter on in the computer scan tool is gonna read 0 volt if it's shorted in the sensor, right? The sensor is going to read 0 volt if it's shorted inside the sensor. So what's the scan tool? Go and disconnect the sensor. This is going to do what? Jump to 5 volt. Because we disconnect the path for that 5 volt to drop to 0. That way you know the sensor is the problem. That's it, you're done. Because you're getting earth, otherwise they can't have a short inside the sensor without getting the right earth. And it's getting 5 volt to the sensor because without getting the 5 volt, it cannot short, right? And the scan tool is not going to read 0 if the 5 volt or the earth was missing. So your job is done, your diagnostic is done right there. Alright, basically that's how it works. If you understand the why and how and the basics, how they work, you can tackle a lot of sensors in automotive without having to, go through the wiring diagram for every different car and understanding. A lot of the time you can learn this type of skills, and then you can tackle any car. Doesn't matter if it's Chinese car or European car or American car, all temperature sensor works the same. But the diagnostic we did today, the charge air temperature sensor was reading too high, causing this fault code, was a little bit thinking outside the box, okay? You really have to think that, okay? Because there's a lot of data on the scan tool. Obviously, sometimes you don't think about looking at that data, or sometimes because it never occurred, never happened, so you miss it, okay? So even if it's right there in your face on the scan tool, you miss that data to watch it, okay? 118 degree, there's no fault code for that sensor, so you never give priority to look at that data. But now you know why it can happen. Maybe next time you'll be careful and watch those data when you have similar problem, okay? No worries, I think I've covered pretty much everything. Thanks for staying, guys. Have a good night, and I'll catch you next time.